Hello everyone, and this is the hour where we are going to talk about electromagnetic waves. It's a small topic, will be covered entirely in 1 hour. One question will come from here for sure in your NEET examination. It's a trend. Every year, one question. The topic is a little bit theoretical, so you need to memorize things here. But for sure, the question coming from here in your NEET examination is one of the simplest question. So keep following everything which I say and practice out some questions from here. For this particular topic, reading NCERT is advised. So without wasting time, let's start learning the topic of electromagnetic waves. The first thing we need to talk about in electromagnetic waves is called Maxwell's equations. Now, what are Maxwell's equations? There is a set of 4 fundamental equations in electrodynamics which are combinedly called the Maxwell's equation. Now, the first equation is nothing but our Gauss law. The Gauss law tells us that the net electric flux coming out of a closed surface equals to Q in by epsilon naught. The term on the left hand side, closed integral of E dot ds, represents the net electric flux coming out. When I taught you guys electric flux, I said that visualize the flux as the number of field line crossing through the area. The more the number of field lines cross, the more is the electric flux linked with the area. The lesser the number of field line cross, the lesser is the electric flux linked with the area. The second equation is called Gauss law for magnetism. And the equation looks like the closed integral of B dot ds equals to 0. The closed integral of B dot ds equals to 0. Sir, you are trying to say that the net magnetic flux coming out of a closed surface always has to be 0. Yes. Why, sir? Because magnetic field lines always form closed loop. If you think of a bar magnet, outside the bar magnet, the magnetic field lines go from north pole to south pole. And inside the bar magnet, the magnetic field lines go from south pole to north pole. So magnetic field lines form a closed loop. Now, if you visualize a Gaussian surface, when the magnetic field line enter, the flux linked with this magnetic field line entering the closed surface will be negative. And when the magnetic field lines exit, the flux linked with this magnetic field line will be positive. Since the magnetic field line form a closed loop, if you visualize any Gaussian surface, anywhere, the number of magnetic field lines entering will always be equal to the number of magnetic field lines exiting. So the flux entering will be same as the flux exiting. As the flux entering will be equal to the flux exiting, you will say that the net magnetic flux coming out of a closed surface has to be equal to 0. This is the second fundamental equation of electrodynamics. The third fundamental equation is nothing but our Faraday's law. Faraday's law says that the EMF generated in a loop equals to minus d phi m by dt. Minus times the rate of change of magnetic flux with respect to time. Now, what is this E? Sir, the EMF. You can write the EMF as minus closed integral of E dot dl. So what you get here is minus closed integral of E dot dl equals to minus d phi m by dt. Cancelling out minus minus both the side. This same equation, which is Faraday's law, can also be written as closed integral of E dot dl equals to d phi m by dt. So here we have got the Gauss law for electron, which tells us that the net electric flux coming out of a closed surface equals to Q in by epsilon naught. We have got Gauss law for magnetism, which tells us that the closed integral of B dot ds, the net magnetic flux coming out of a closed surface is 0 because the magnetic field lines form closed loop. So the number of magnetic field lines entering the closed surface has to be equal to the number of magnetic field lines exiting. Hence, the net magnetic flux linked with a closed surface is 0. The third one, closed integral of E dot dl equals to the rate of change of magnetic flux with respect to time. This statement came from Faraday's law. And now comes the fourth equation, which is nothing but Ampere's circuital law. Ampere's circuital law says that closed integral of B dot dl. If you think of an Amperian loop, think of the magnetic field at any place on this Amperian loop. Think of one infinitely small length element along the length of the loop. Take their dot product and keep on doing this for the whole loop and add it up. Then the closed integral of B dot dl comes out to be equals to mu naught times the current inside this Amperian loop. We have done this already. Now bachon, this fourth equation is called the Ampere's circuital law. Maxwell believed in the symmetry of the universe. The third equation, the Faraday's law, tells us that a time varying magnetic field gives rise to an electric field. So one can have a basic argument based on the symmetry of universe that if a time varying magnetic field gives rise to electric field, will a time varying electric field give rise to magnetic field? Now, just by assumption, you can't assume things to be true in life. You have to do experiments in physics. So where can I find a time varying electric field so as to detect that does that time varying electric field gives rise to magnetic field or not? It's easy to find between the plates of a capacitor. Let's say you have got these plates of a parallel plate capacitor connected to an AC source. So as the potential drop across the plates will keep on changing, since the source is alternating current source, so will the potential drop across the plates. As the potential drop across the plates of the capacitor will keep on changing, so will the charge on the capacitor plates. Now let's say at some goddammit instant of time, the charges on these two plates is plus Q and minus Q. So we know that the electric field in the region between the plate will be equals to Q by epsilon naught A, where A is the plate area. Now as the potential will keep on changing because the source is AC, so will the charge on the plate and so will the electric field. So as to test whether the argument that a time varying electric field gives rise to magnetic field or not, detect that as the electric field strength between the plate keeps on changing, do we find magnetic field at a place between the plates? And it was found that yes, there is a magnetic field between the plates due to this time varying electric field. So if we think of an Amperian loop here, we know that magnetic field is present at all points on this Amperian loop. And the closed integral of B dot dl is non-zero. But this violates the Ampere's circuital law. Why? In the region between the plates, there is only electric field, and that changes with time due to the change in charge. If you think of an Amperian loop here, for this Amperian loop, the closed integral of B dot dl is non-zero. But there is no current flowing from this loop. Since there is no current flowing from this loop, how can you have a non-zero quantity equal to a zero quantity? This means that something is wrong with the Ampere's circuital law, and Maxwell made the correction. He said that when I write closed integral of B dot dl equals to mu naught IC, here I have written the subscript C because IC represents the conduction current. That is the type of current which flows in a wire. Why do we call it conduction current? The simple reason we call it conduction current because it flows in a wire due to the motion of electrons. An electron moves within the conductors. That's why I call conduction current. Now, if we have a time varying electric field, we found this from experiments that a time varying electric field also gives rise to magnetic field. So if we think of an Amperian loop, within this Amperian loop, there is no conduction current. There is no wire carrying current, but still you get magnetic field. So you still get closed integral of B dot dl. So Maxwell did some correction. He placed an additional term apart from IC and he changed the Ampere's circuital law to this. He said that the closed integral of B dot dl should be written as mu naught times IC plus IT. What is IC? The conduction current which flows in a wire. And he added an extra term ID. Here ID is called displacement current. And this current arises due to the changing electric field. Do understand that when I say ID, displacement current, it is just a way to make this equation work. There is no such charge flowing in the form of displacement. So do not think that there is some charge flowing here. Now these four equations, the Gauss law for electron, the Gauss law for magnetism, the Faraday's law and the Ampere's Maxwell's circuital law, because Maxwell did the correction. These four equations together are called the Maxwell's equation. Now here we need to talk more about this term, which is called the displacement current. Now the displacement current, or ID, is defined to be equals to epsilon naught times the rate of change of electric flux with respect to time. Displacement current is epsilon naught times the rate of change of electric flux with respect to time. Once more, the displacement current is epsilon naught times the rate of change of electric flux with respect to time. So let's understand this more with one example. The example goes like, show that the displacement current is equal to conduction current during the charging of a capacitor. So our mission is to show that if you have got this capacitor plates and they are being charged using some conduction current, then the displacement current between the plates is going to be equals to conduction current, and this same question came few years back in your NEET examination. So let at an instant the magnitude of charge on the plate of capacitor to be Q and the area of each plate to be A. So visualize the capacitor plates. Think that the charge on the capacitor plates at this instant is plus Q and minus Q, and the plate area is A. Now beta, our mission is to prove that the conduction current, that is the current in this conducting wire, is equal to the displacement current between the plates. Do remember the definition of displacement current. Displacement current equals to epsilon naught times the rate of change of electric flux with respect to time. Once more, epsilon naught times the rate of change of electric flux with respect to time. So we will say that electric field between the plates of the capacitor, when the capacitor plates have charge Q and minus Q, will be nothing but Q upon epsilon naught A. So the electric field strength will be equals to Q upon epsilon naught A. Keep this equation in mind. Now we know that the displacement current is epsilon naught times the rate of change of electric flux with respect to time. Now if between the plates the field strength is Q by epsilon naught A and the plate area is A, then what will be the electric flux linked with this area A? So you will say that since the electric field is uniform, I can simply write the electric flux to be nothing but the electric field strength multiplied by area. So that comes out to be Q upon epsilon naught A multiplied by A get cancelled, you get simply Q upon epsilon naught. So when the charge on the capacitor plate is plus Q and minus Q, then the flux linked with an area A between the plates is nothing but Q upon epsilon naught. Do remember that the displacement current is epsilon naught times the rate of change of electric flux with respect to time. So the displacement current ID is given by epsilon naught times the rate of change of electric flux with respect to time. You know that when the charge on the plate is Q, the electric flux is Q upon epsilon naught. So you will say that the displacement current is epsilon naught times the rate of change of Q upon epsilon naught with respect to time. So you will write it as epsilon naught times d by dt of Q by epsilon naught. This epsilon naught is constant, it can be taken out of the differentiation. Once you take it out, these two epsilon naught get cancelled. So what you get is epsilon naught times 1 by epsilon naught times dq by dt. If you cancel them, it's nothing but dq by dt. What is dq by dt? The rate of change of the charge on the capacitor plate with respect to time. Who is changing this charge on the capacitor plate? Sir, the current through the conducting wire. So dq by dt is nothing but the conduction current. So you need to remember this result, that if you are charging a capacitor using some current, then the displacement current in between the plates is equal to the conduction current in the wire which is charging or discharging the capacitor plate. This is a simple important result that you must remember. Now we will talk about sources of electromagnetic waves. We know that an electric charge at rest produces only electrostatic field around it. So if you have a charge at rest, it produces only electrostatic field lines. The electrostatic field lines originate at positive charge and they terminate at the negative charge. A charge moving with uniform velocity constant velocity. When I say uniform velocity, it means that same magnitude, same direction. Velocity is a vector quantity. So a charge moving with uniform velocity, same speed, same direction, that is steady current, produces both electric field and magnetic field around it. So a charge at rest produces only electrostatic field lines. A charge moving with constant velocity produces both electric field and magnetic field. And an accelerating charged particle produces both electric field and magnetic field, which varies with space and time, which forms electromagnetic waves. So remember that a charge at rest, only electric field. A charge moving with constant velocity, same magnitude, same direction, produces electric field plus magnetic field. An accelerating charged particle produces electric field, magnetic field, as well as electromagnetic radiations, which are called EM waves. Now let's talk more about EM waves. An electron orbiting around its nucleus in an stationary orbit does not emit electromagnetic waves. This statement is which statement? This is the first Bohr's postulate. To explain that, when an electron revolves around the nucleus, the velocity of electron is not constant. It's accelerating. The direction of velocity is changing. So if the electron is accelerating, it must be giving out electromagnetic radiations. And if the electron gives out electromagnetic radiation, then its energy should keep on decreasing and the electron should eventually spiral down into the nucleus. But we know that if this will happen, then all the electrons will spiral down into the nucleus and there will be no nucleus at all in this universe and you and me won't exist. So this can't be true. Since Bohr had no explanation for this, he took it as a postulate. And he said that an electron orbiting around its nucleus in a stationary orbit does not emit electromagnetic wave. This comes from the first Bohr postulate. It will emit only during transition from higher energy orbit to lower energy orbit. So as to go from lower orbit to higher orbit, the electron absorbs EM waves, a photon, and it goes from lower orbit to higher orbit. And when the electron jumps from higher orbit to lower orbit, it gives out a photon. It gives out radiations. Next point, electromagnetic waves, X-ray, is produced when high-speed electrons enter into the target of high atomic weight. How are X-rays produced? We take an electron gun, and through this electron gun, after accelerating electrons, we shoot them on metal having large atomic mass. When the electrons go and hit here, we know that the electrons get scattered as well as one more type of radiation is produced. This one more type of radiation that is produced is called X-rays. X-rays are a type of electromagnetic radiations. So electromagnetic waves, X-ray, is produced when high-speed electrons enter into the target of high atomic weight. The next point that you should know. Electromagnetic waves, gamma rays. Gamma rays are the most energetic of all the EM waves. Gamma rays are produced inside the nucleus whenever some nuclear reaction takes place. So electromagnetic waves, gamma rays, is produced during de-excitation of nucleus in radioactivity. So just remember that X-rays are produced by bombarding high energy electrons on high atomic weight atoms. And gamma rays are produced during the nuclear reaction. Gamma rays are produced within the nucleus. Now let's continue and talk more. Important characteristic of electromagnetic waves that you must know. The first one, it is produced by accelerating charge. Electromagnetic radiations are produced by accelerating charge. A charge at rest produces electrostatic field line. A charge moving with constant velocity produces electric field as well as magnetic field. And we know that an accelerating charge produces EM waves. So it is produced by accelerated charges, example in case of X-ray, and oscillating charges as in the case of LC oscillations. Second, it travels in free space. All the electromagnetic waves travel in free space at the speed of 3 into 10 raised to the power of 8 meters per second. I know that you know this already, and which is denoted by the letter C. So what is C? C is the speed of light. Understand that light is only one small part of the entire electromagnetic wave spectrum. Radio wave is also EM wave. X-rays are also EM waves. Gamma rays are also EM waves. But only one small part of this whole spectrum which our eyes can detect is called light. So light travels at speed of 3 into 10 to the power of 8 meter per second. The symbol used to denote 8 is c. Remember that all EM waves move at the same speed c. Now this c comes out to be equals to 1 by under root of mu naught a naught. You need to remember this. This question is asked so many times in units and dimension. What is the dimension of 1 upon under root of mu naught e naught? 1 upon under root of mu naught e naught is nothing but the speed of light. So the dimension of 1 upon under root of mu naught e naught has to be same as the dimension of speed, which is Lt minus 1. Now bacho, next point. These waves do not require material medium for their propagation. Obviously, EM waves are non-mechanical in nature. Next point. In these waves, the electric field vector and magnetic field vector vary sinusoidally. This point I will say is the most important point. Be careful. In these waves, the electric field vector and the magnetic field vector vary sinusoidally. The electric field and magnetic field become maximum at same place at the same time. Once more, the electric field vector and magnetic field vector become maximum at the same place at the same time, but perpendicular to each other as well as to the direction of propagation. So when the EM wave propagates, the direction of variation of electric field, the direction of variation of magnetic field, and the direction of propagation, all three are mutually perpendicular. But the important point I'm trying to emphasize here is this. Electric field and magnetic field become maximum at the same place at the same time. Now, next thing. Therefore, the phase difference between the two fields is zero. They become maximum together. They become zero together. They become negative maximum together. They become zero together. They become positive maximum together. They become zero together. They become negative maximum together. They become zero together. The direction of oscillation of electric field, the direction of oscillation of magnetic field, and the direction of propagation are mutually perpendicular. Okay. But the important point here is that they become maximum at the same place simultaneously. It means that they are in same phase. Since they are in same phase, the phase difference between the two fields is zero. You need to remember this. This is important point. The next important point coming up. The amplitude of electric field and magnetic field are related to each other as the speed of light equals to the electric field amplitude upon the magnetic field amplitude. Or you can think of it this way. The electric field amplitude will always be 3 times the magnetic field amplitude. Or you can think of it this way. The electric field amplitude will always be 3 into 10 to the power of 8 times the magnetic field amplitude, given that the wave is moving in vacuum. So the electric field amplitude is way bigger than the magnetic field amplitude. 3 into 10 to the power of 8 times bigger. Next thing, bacho, this is again important point. The direction of propagation can be represented by the direction of electric field vector cross magnetic field vector. I told you this case is important because this is the case of light. When I taught you about a charged particle projected in electric as well as magnetic field, and the charged particle goes without deviation to both of them in such a way that the velocity, electric field and magnetic field, all three are perpendicular, I said that this case is same as the case of light. And this is the beauty of physics. Things are connected so well. If you remember this, you will remember that. If you remember that, you will remember this. So once input, twice output. Now bacho, again, since this is an important point, I will explain the entire point again. This is the most important point I will say. In the EM waves, electric field and magnetic field vary sinusoidally. Electric field and magnetic field become maximum at the same place at the same time, but perpendicular to each other as well as to the direction of propagation. So the direction of vibration of electric field, the direction of vibration of magnetic field, and the direction of propagation are perpendicular. Next thing, beta. Since the electric field and magnetic field becomes maximum together, again zero together, negative maximum together, again zero together, they are in same phase. So the phase difference between them is zero. So therefore, the phase difference between the two fields is zero. Next thing, The amplitude of electric field and magnetic field are related to each other as the speed of light equals to the amplitude of electric field upon the amplitude of magnetic field. And the last point here, important point here. The direction of propagation of EM wave is same as the direction of E cross B. So if an EM wave is propagating and you find that the direction of electric field is towards north, the direction of magnetic field is downwards. What will be the direction of propagation of the EM wave? So sir, simply find out the direction of E cross B. Align the finger of right hand in direction of north and curl the fingers towards down. The direction of thumb is towards west. So this wave must be propagating towards west. So this is the most important point. So let's visualize this with a diagram. Think of this being x, y and z axis. Notice that x cross y gives you z. Now, if the electric field vibrates in the x direction, positive maximum, then negative maximum, then positive maximum, and keep on oscillating at every place, then the magnetic field which oscillates in the y direction looks like this. Notice that at the same place they are maximum together, at the same place they are zero together, at the same place they are negative maximum together, then again at a place they are zero together. So both the EM waves are in same phase, and the direction of propagation is same as the direction of E cross B towards positive x. So this is something important. If you haven't got any point, go back, listen to it again. This is the most important point. Now moving on. The velocity of EM waves in a medium is decided by the electric and magnetic properties of the medium, not by the amplitude of the electric and magnetic field vectors. So I have said it many a time. The speed of a wave in a medium depends upon medium. It does not depend upon the source. Just like for vacuum, we say that the speed of light in vacuum is given by 1 by under root of mu naught epsilon naught. We say that the speed of light in a medium is given by 1 upon under root of permeability of the medium times permittivity of the medium, rather than permeability of free space and permittivity of free space. You just substitute for a medium permeability of the medium and the permittivity of the medium. So the speed of electromagnetic wave in a medium is, say, V equals to 1 upon under root of permeability of the medium times permittivity of the medium. Now you can even write in place of permeability of the medium mu r into mu naught, and in place of permittivity of the medium you can write relative permittivity multiplied by permittivity of free space. Now let's talk ahead. The energy carried by electromagnetic wave is equally divided between the electric field and magnetic field. Now here comes a simple question. Who gave the law of equipartition of energy? Maxwell. Who gave the theory of EM wave? Maxwell. There, while teaching UKTG, I said that the energy associated with each degree of freedom is equal. And we said that the total internal energy equals to F by 2 n RT, where F is the number of degree of freedom, right? The same Maxwell gave us the theory of EM waves. And here also, he told us that the law of equipartition of energy is valid even here. And the law says that the energy is equally divided between electric field and magnetic field. We say that the total average energy due to both electric field as well as magnetic field is given by the total energy density, energy stored per unit volume, equals to half epsilon naught E peak square, the amplitude of electric field whole square, or this can also be written as B peak whole square by 2 mu naught. Now students ask me, sir, this half epsilon naught E square is the energy stored in the form of electric field only, na? Yes. And this B square by 2 mu naught is the energy stored only in the form of magnetic field, na? Yes. Then sir, why are you saying that the total average energy due to both equals to half epsilon naught E peak square equals to the peak value of magnetic field whole square divided by 2 mu naught? To understand that, in case of EM wave, the electric field keeps on oscillating, yes. If I ask you what is the strength of electric field at a point at any time t, the equation looks something like the same as the equation of propagation of transverse wave. So the electric field at a position x at any time t is given by, let's say, E naught sine omega t minus kx. So at one point, the electric field is not constant. It keeps on changing. Yes, sir. So if I ask you what is the energy density at this point at any time t, you will say that, sir, the energy density, that is the energy stored per unit volume, will be equals to half into epsilon naught into the electric field here at any time t whole square. That will be equals to E naught square sine square omega t minus kx. Now if I ask you what is the average energy density because of electric field at this point, so when you find the average energy stored per unit volume due to the electric field, you need to take the average value of sine square omega t minus kx, and the average value of sine square omega t minus kx is half. So what you get, only due to the electric field, the average energy density at a place is half epsilon naught E naught square into half. So that comes out to be 1 by 4 epsilon naught E naught square. This is the energy only due to electric field. But we know that the same amount of energy is also associated with the magnetic field. So the total energy has to be double the energy due to the electric field alone. That's why the total energy came out to be half epsilon naught E peak whole square. So once again, emphasizing here, the energy stored per unit volume in the form of electric field will be half of this. That will be 1 by 4 epsilon naught E peak square. But since we know that the energy is equally distributed both in the form of electric field and magnetic field, the energy associated with the electric field only is 1 by 4 epsilon naught E peak square. Same amount of energy has to be associated with the magnetic field as well. So the total energy has to be double of this. That's why you get 1 by 2 epsilon naught E peak square, and which is same as B naught square by 2 mu naught. Okay. Remember this point. This is an important point. This is the expression for total energy. If they ask you what is the energy associated only with electric field, that is 1 by 4 epsilon naught E peak square, or 1 by 4 B naught square by mu naught. So let's move on to the next point. Electric field vector of an EM wave produces optical effect, hence also called light vector. This is a famous question. We know that electromagnetic wave can be expressed both as variation of electric field as well as magnetic field. Our eye detects the variation of electric field or the variation of magnetic field. So the answer is our eye detects the variation of electric field vector. That's why the electric field vector of an electromagnetic wave produces the optical effect. Hence it is known as the light vector. So let's talk ahead. Let's continue ahead. Electromagnetic wave is not deflected by electric field as well as magnetic field. Obviously, it is not at all carrying any charge. So there is no electrical force on it. There is no magnetic force on it. So you can't deflect EM waves using electric field or magnetic field. The next point, and this is important. Intensity of electromagnetic wave is defined as energy crossing per second per unit area perpendicular to the direction of propagation of EM wave. So intensity associated with an EM wave is nothing but the energy crossing per unit area per unit time. Now, if you remember the formula of energy density of EM wave, to remember the intensity of EM wave is very easy. I have just taught you guys that the energy density, that is the energy stored per unit volume, is given by half epsilon naught the amplitude of electric field whole square, and that is equal to the amplitude of magnetic field whole square divided by 2 mu naught. Remember that this is the net energy density due to both electric field as well as magnetic field. Now let's assume that we have got an EM wave propagating in a cylindrical region, and let's say this cylinder has a length L and this cross section area is A, and let's say here EM waves are moving. We know that EM wave move at the speed of light. So the time taken by all the EM wave within this region to hit the surface will be equals to L by C. We know that the energy stored per unit volume, energy density, is half epsilon naught E peak whole square. So the total energy that will hit this area in a time L by C will be nothing but the energy density multiplied by the volume, which is A into L, the volume of the cylinder. So you will say that the intensity is nothing but energy incident per unit area per unit time on this surface. So the energy incident total will be half epsilon naught E peak whole square into AL per unit area per unit time, and the time will be L by C. So move this C from the denominator of denominator to the numerator. Cancel out the A and the L and L. So you get that intensity is nothing but half epsilon naught E peak whole square multiplied by the speed of light. So it's easy to remember that the average intensity is given by intensity equals to half epsilon naught E peak whole square into the speed of light. This quantity right here is nothing but the total energy density of the EM wave. So you get that intensity is nothing but the energy density multiplied by the speed of light. Once more, the intensity is nothing but the total energy density multiplied by the speed of light. Now here again, as the electric field varies sinusoidally, you can say that the RMS value of the electric field equals to E peak by root 2. So here, rather than writing half epsilon naught E peak whole square, you can write it as epsilon naught E peak by root 2 whole square. So this epsilon naught into E peak by root 2 whole square can even be written as epsilon naught times E RMS whole square. So these two are one and the same thing. Similarly, rather than writing here half epsilon naught E peak whole square, you can write B peak whole square by 2 mu naught. So this is how you write the intensity in terms of electric field. And when you have to write the same intensity, which is the energy transferred by the EM wave per unit area per unit time, can also be written in the form of magnetic field as intensity equals to B peak whole square by 2 mu naught into C, and in place of B peak whole square by 2 you can write B RMS whole square, or that can also be written as B RMS whole square by mu naught into C. This is how you write the intensity of EM wave in the term of magnetic field. Now I will talk about something about light which can't be explained using the wave nature, which can be explained very easily using the particle nature. We are going to talk about the momentum and the pressure exerted by light. So first, electromagnetic wave carry energy as well as momentum, and the momentum associated with the light is given by the energy upon the speed of light. So the momentum associated is nothing but energy upon the speed of light. So here remember that U is the energy carried by the EM wave in free space and C is the speed of EM wave in free space. Sir, how can you say this? To explain this, I will have to explain using the photon theory. We know that the energy of one photon is given by Sc by lambda. Yes, sir. And let's say when an EM wave propagates, you have got n number of photons. So you will say that the total energy that is propagating is nothing but n times the number of photons multiplied by the energy of each photon, Sc by lambda. This is the total energy that is propagating. And from de Broglie's hypothesis, we know that the momentum associated with one of the photon will be equals to h by lambda. If you have got n number of photons moving, then the total momentum will be equals to nh by lambda. So looking at energy equals to n times Sc by lambda and momentum equals to nh by lambda, if I bring this C down here, on the left hand side I will get U by C equals to nh by lambda, and this nh by lambda is the combined momentum of all the photons, and that is nothing but the total energy upon the speed of light. So I know that this shouldn't be placed while teaching you EM waves, but since we are talking about light, I thought that this point should be covered here as well. So the momentum associated with the propagation of light is nothing but the energy carried by it upon the speed of light. You need to remember this relationship. The next thing we are going to talk about is called radiation pressure. So radiation pressure is defined as the force exerted by the EM wave per unit surface area. We have just learned that if we have got some surface area, an EM wave come and let's say gets absorbed on this surface. So this is a black body. Okay, black body. It absorbs the radiation falling on it. So we know that when this EM wave propagates, it has got some momentum associated with it. Once it gets absorbed, the momentum becomes zero. To change the momentum, you need to apply a force. So as to change the momentum of all these hitting photons, there has to be a force on the photons. And by Newton's third law, if the plate which is absorbing these photons applies some force on the photons will apply equal and opposite force on the plate. And this force acting per unit plate area is called the radiation pressure. So you need to understand that when EM wave move, when light move, it has got momentum associated with it. Whenever this momentum changes, some force must act. So the light will apply force on the object interfering in its path. And this force acting per unit area is called the radiation pressure. Now there can be two cases. The first case, if the surface absorbs the radiation falling on it, then the radiation pressure P is given by the intensity of the EM wave upon the speed of light. So for 100% absorption, the radiation pressure is I by C. For 100% absorption, the radiation pressure comes out to be I by C. Next point, if the surface reflects completely the radiation falling on it, then the radiation pressure P is given by 2I by C. Why? Think of it this way. If you throw a ball of mass m towards a wall with a speed v, if the ball collides and comes to rest, if it gets absorbed in a way, then the change in momentum of the ball is mv. But if ball after collision goes back with the same speed in the opposite direction, then you will say that for this case the change in momentum of the ball is 2mv. So in case of reflection, the change in momentum is double. Since the change in momentum per unit time is double, the force is double. And if the force is double, the radiation pressure has to be double. So just remember that for 100% absorption, radiation pressure is I by C. And for 100% reflection, the radiation pressure is 2I by C. What is I? Intensity of the EM wave. What is C? The speed of light. Let's move ahead and talk relationship between electric field, magnetic field and the speed of light. So sir, we already know that the speed of light is nothing but the peak value of electric field upon the peak value of magnetic field. Dividing both numerator and denominator with root 2, you can even write this as ERMS, the RMS value of electric field vector upon the RMS value of magnetic field vector. So let's say a plane electromagnetic wave is propagating along the x-axis. Electric field and magnetic field vectors are oscillating along the y direction and the z direction. So electric field vector oscillating along the y, magnetic field vector oscillating along the z, and the EM wave propagating along the x. So E cross B gives you the direction of propagation. We will say that the electric field at any position x at any time t will be given by Ey equals to E naught sine kx minus omega t. Similarly, the magnetic field oscillating in the z direction will be given by Bz equals to the peak value of magnetic field times sine kx minus omega t. Sir, how did you know that this input will be same and the trigonometric function will be same? Because the electric field and magnetic field oscillations are in the same phase. That's why I have kept this trigonometric function same as well as the input same. Now bachcho, here k is nothing but 2 pi by lambda, which is called the propagation constant or the angular wave number. Second thing bachcho, the omega is nothing but the angular frequency, which is also equals to 2 pi f. We have learned all of this in the topic of waves already. Now here E naught and B naught are amplitude of electric field and magnetic field respectively. We know that omega by k gives you what? I told you guys now, omega equals to kV. So omega by k is nothing but the speed of the propagating wave. If the wave travels in vacuum, then this speed has to be same as the speed of light, which is 3 into 10 to the power of 8 meter per second. Now in place of omega, you can write 2 pi f. In place of k, you can write 2 pi by lambda. So the 2 pi get cancelled. The lambda moves from denominator of denominator to the numerator. So that becomes equals to f lambda, and f lambda is nothing but speed of the wave. Now I know that you know most of this. The thing which I wanted to emphasize was that the speed of light is nothing but E naught by B naught. And second thing, the phase of electric field and magnetic field is same. So now let's do an example based on this. The oscillating magnetic field in a plane electromagnetic wave is given by the magnetic field oscillates in the y direction equals to 8 into 10 to the power of minus 6 sine 5000 pi x minus 3 into 10 to the power of 11 pi t Tesla. Your mission is to find the frequency of the EM wave, the wavelength of the EM wave, and the speed of the wave. Once you know k and omega, finding all these three things are easy. Frequency can be found using omega equals to 2 pi f. Omega is given, you can find out the frequency. Wavelength can be found using k equals to 2 pi by lambda. K is given, you can find out lambda. And to find the speed of wave, either use, once you have found frequency, once you have found wavelength, simply multiply them, you will get the speed. Or bachon, we know that omega equals to kv, so the speed can be written as omega by k. Omega is given, k is given, simply divide them, you will get the v. So let's do it. Comparing given equation with the standard equation, which is by equals to b naught sine kx minus omega t, we can see that k is nothing but 5000 pi and omega is nothing but 3 into 10 to the power of 11 pi. So you will say that omega equals to 3 into 10 to the power of 11 pi, which is same as 2 pi f equals to 3 into 10 to the power of 11 pi, cancelling out pi. The frequency comes out to be 1.5 into 10 to the power of 11 hertz. Easy. Now, to find the wavelength, you will use k equals to 2 pi by lambda. The value of k is given as 5000 pi. So you will write lambda equals to 2 pi by 5000 pi, cancelling out pi, you get 2 by 5000, which you will get equals to 0.4 into 10 to the power of minus 3 meter. Or you can say that the wavelength is 4 into 10 to the power of minus 4 meter. Or you can write the wavelength to be equals to 0.4 mm. Now to find the speed, simply multiply frequency with wavelength or use v equals to omega by k. So we know that v equals to omega by k. Omega we know, k we know. If we divide them, we will get the speed. So you get 3 into 10 to the power of 11 pi upon 5000 pi. So this is 0.6 into 10 to the power of 8. Definitely, since the speed is not 3 into 10 to the power of 8, this is not vacuum. This is some other medium. So this speed is same as 6 into 10 to the power of 7 meter per second. Now let's look at extension of the same problem. The oscillating magnetic field in plane EM wave is given by by equals to 8 into 10 to the power of minus 6 sine 5000 pi x minus 3 into 10 to the power of 11 pi t Tesla. This time you have to tell first the electric field amplitude, and second, write down the expression for oscillating electric field. Now how to do this? First, let's find out the electric field amplitude. Comparing this given equation with the general equation, which is by equals to b naught sine kx minus omega t, we can find out what is the value of k, what is the value of omega, and using k and omega we can find out the speed, which we have already done in the last question, and that came out to be 6 into 10 to the power of 7 meter per second. We know that the speed of the EM wave is nothing but E naught by B naught. B naught is given. V we have already found 6 into 10 to the power of 7. So the amplitude of electric field will be nothing but V into B naught, and V is given as 6 into 10 to the power of 7 and B naught is given as 8 into 10 to the power of minus 6. So here you get 6 into 8, 48 into 10 to the power of 1, that is 480 volt per meter. So now you know what is the electric field amplitude. If they ask you the RMS value of the electric field vector, simply divide this with root 2. Now the second part of the question, write down the expression for oscillating electric field. So first of all, we need to understand that the trigonometric function will be same both for electric field as well as magnetic field. And second thing, the peak value of electric field, rather than having 8 into 10 to the power of minus 6, you will simply get 480. But the part which students do wrong here, what will be the direction of oscillation of electric field? So do understand that here the wave propagates in x direction. So how do you know? If they have given you kx minus omega t, it means that the wave moves in x. So the wave moves in x. The magnetic field is in y. in which direction you should have electric field so that E cross B comes out to be in X. So sir, all three have to be mutually perpendicular. So if the wave propagates in X and magnetic field in Y, then electric field should be in Z. So you will say that the electric field in Z direction equals to 480, here just write 480, and the rest trigonometric function same because they are in same phase. So as the wave is traveling along the x-axis, we know that E cross B should be along the x-axis. So minus times of k cross j gives you I cap. So this tells us that the electric field vector should be in the Z direction. So you will say that the variation of electric field in Z direction equals to the electric field amplitude 480, and the whole trigonometric function is same as the electric field and magnetic field are in same phase. Now let's talk about intensity of a point source at some distance r from it. So let's say we have a point source, and this point source gives out EM waves. We need to know what will be the intensity of the EM wave at a distance r from this point source. So how to find? Let's see. So let's say the power of this point source is P. So here we have a point source whose power is P. So the energy coming out of it per unit time is P. And let's say we need to find the intensity due to this point source at a distance r from it. So at a distance r from it, the energy given out by this point source will get distributed over a sphere of radius r. We know that bacho, distance of point A where we need to find the intensity is, let's say, r. So distance of A where intensity is to be calculated is r. We know that bacho, intensity is nothing but energy crossing per unit area per unit time, and the energy crossing per unit time can be written as power. So intensity can be written as power upon area. We know that the power of this source is P, and the same power gets distributed over a spherical surface of surface area 4 pi r square. So the intensity due to a point source of power P at distance r from it will be nothing but the power of the source divided by the area over which this power gets distributed. So the intensity due to a point source at distance r is given by nothing but power of the source upon 4 pi r square, and the unit of intensity is watt per meter square. Watt, unit of power, upon meter square, the unit of area. So this is one simple important correlation that you should know. Now we will talk about the electromagnetic spectrum, and that's the end of this hour. So let's talk about electromagnetic spectrum. Here we will talk about all type of EM waves. So we know that electromagnetic waves include gamma rays, the most energetic, produced inside the nucleus, then X-ray, the next most energetic. X-rays are created when high energy electrons are bombarded on heavy metals. Third, ultraviolet rays, again they have got higher energy than the visible. They can cause skin cancer due to the mutation in chromosome. Then there is visible light, our darling light, which we use to see this beautiful world. Then there is infrared, which is emitted by hot objects. Then there are microwaves, which you use to cook your food. And then there are radio waves, which are used for telecommunication. All these different waves are nothing but EM waves. They get reflected, they can be polarized, they can be refracted. They show all the properties of EM wave. They travel in vacuum at the speed of 3 into 10 raised to the power of 8 meters per second. So in the nutshell, all of these waves are combinedly called EM waves. Now bacho, let's talk about them one by one, starting from the lowest energy one. Lowest energy means maximum wavelength, means lowest frequency. So when we talk about radio waves, it is produced by accelerated motion of charges in conducting wires. You might have seen antennas. So some current flows through them, and this current is nothing but the flow of charge. And due to the acceleration of these charges, these radio waves are created. Now they have got less energy, they are used for telecommunication. By oscillating electric current, you can produce radio waves. Its frequency is from the range of 500 kilohertz to 10,000 megahertz. Now to be true, I do not remember this. I have looked into the book to get this point here. So do I personally remember all these things? No, I just remember that radio waves have got the least of energy. So they have got the least of frequency and the highest of the wavelength. Next, its wavelength range is, again, I have copied this from a book, 10 raised to the power of minus 2 meter to 10 raised to the power of 4 meter. So now we will talk about the microwaves after the radio waves. The microwaves have got more energy than radio waves. So let's talk about microwaves. It is produced by special vacuum tubes. These vacuum tubes are called klystrons, and in magnetrons and in gun diodes you can produce them. Now do not need to remember gun diode and klystrons, but magnetrons are the one used to create microwaves. Remember this one. Second thing, beta, its frequency range is from 1 gigahertz to 300 gigahertz. So do you remember this? Sorry to say I don't. The uses of microwaves are following. The first one, it is used in radar system for aircraft navigation. So these type of question might come in your examination as the examination is becoming more and more theoretical. Which of the following EM waves are used for aircraft navigation? So the answer is microwaves. Second, it is used to detect speed of tennis ball, cricket ball and automobiles. So in the cricket match, when they display the speed of the ball, that speed is detected using microwaves. Next point, it is used in microwave ovens. Now, as a child, it was always my doubt that since visible has got more energy than microwaves, then how come that microwaves can be used to cook food while visible can't be? Because all our food contains something called H2O, and the natural frequency of vibration of water matches with that of microwaves. So when microwaves, the same frequency, EM waves are bombarded on water, the molecules undergo resonance and they oscillate vigorously with higher amplitude, leading to heating up of our food as all our food contains water. So now moving on to the next type, which is infrared waves. So it is produced by hot bodies which are at a little bit higher temperature. That is vibration of atoms and molecules. So when the temperature of a body increases, the vibration of the molecule increases, and due to the vibration of atoms and molecules, we get infrared waves. Hence, these waves are also called heat waves. So they might ask you, which type of EM waves are also called heat waves? So you do not need to give the answer as gamma rays, as they are the most energetic wave. Heat waves are nothing but infrared waves. So now, it is not detected by human eye. Obviously, we can't see infrared waves, but snakes can detect it as well as many other animals. But snake is written in NCERT, that's why it has been placed here. Next, these waves are readily absorbed by water, CO2 and NH3. So that's why these waves are the one responsible for greenhouse effect. Next, its frequency range from 10 raised to the power of 11 hertz to 10 raised to the power of 14 hertz. So do you remember it? No. So do we need to remember this? I said that there is very less chance of this being asked in your NEET examination, but still you can read it. Next, its wavelength lies from 1 millimeter to 700 nanometer. I remember this 700 nanometer. Why? Because I remember the range of wavelength of visible light. So I know that the upper limit of infrared wave is same as that of the visible light. Moving on, it is detected by thermopile bolometer infrared photographic film. So as to detect it, they might ask thermopile bolometer and infrared photographic film. Next, moving on to the uses of infrared radiation. The first use, infrared lamps is used in physical therapy, that is to treat muscular strain. So since you are going to be a doctor and some of you might become orthopedic, you should know that infrared radiations are nothing, the radiation given by hot objects. So you take up a stone, you heat it up and you place it at a place where the patient have muscular cramp. The radiation coming out of the hot stone are infrared radiation. So infrared lamps is used in physical therapy. Second, it is responsible for keeping the average temperature through greenhouse effect. So infrared radiations are the one responsible for showing greenhouse effect. Keep this in mind. Third point, infrared detectors are used in Earth satellite both for military purpose and to observe growth of crops. Human beings give out infrared radiation. So if you need to know where are more units of a particular army stationed, you can detect them even when they do not use any light using the infrared detectors. So human beings give out infrared radiation. So you can detect where is more accumulation of armaments using infrared detectors. Next बच्चों, to provide electrical energy to satellite by using solar cells. So solar cells actually absorb infrared radiations the most, and these solar cells are used to supply power in the case of satellite. Definitely you can't connect an electrical wire from Earth's surface to the satellite, so you have to place solar panels over the satellite, and these solar panels absorb infrared radiations the most. The next point, to take photographs during fog and smoke. Definitely during fog and smoke you don't have the visible light, so we use infrared radiations to take the picture. The next point, it is used to study molecular structure by taking infrared absorption spectrum. So it can also be used to study the crystal structure of substances. Why do we need to know all these points? Because they are given in NCERT, so you need to know them. The next type of wave we are going to talk about is the visible light, which is the most important one. It is a narrow range of electromagnetic spectrum. Calling the whole electromagnetic spectrum as light is wrong. So we should understand that the small part of the entire electromagnetic spectrum that we can see is light, and hence to make you understand it better we call it visible light. Now it is produced by atomic excitation. You might have learned that the transition of Balmer series lies in the visible region. So it is produced by atomic excitation. So when the electron moves within the atom. Next बच्चों, its frequency range from 4 into 10 to the power of 14 Hertz to 7 into 10 to the power of 14 Hertz. This is something I remember. Next, the wavelength lies between 700 nanometer to 400 nanometer. In some book, you will find 750 nanometer to 450 nanometer. But since visible light is the light we see, you need to remember this data. Moving on, the visible light emitted or reflected from an object around us provide us the information about the world. Obviously, that's the only type of EM wave a human eye can detect. So visible light provides us the whole knowledge of this universe. Next point, it is detected by eye, photocell and photographic film. This is something you already know. So the next type of wave we are going to talk about is ultraviolet rays. Now it is produced by sun or the things which are at very high temperature, spatial lamps and very hot bodies. Now this is something important for all future doctors. So its frequency lies between 8 into 10 to the power of 14 and 5 into 10 to the power of 16. Sir, do you remember this? Yeah, the lower limit I remember because for visible light we have taken 7, so here 8, but I do not remember the upper limit. Its wavelength lies from 400 nanometer to 0.6 nanometer. I remember this 400, but this 0.6 I do not remember. Next point, it is detected by photocells and photographic films. Next point, most of the ultraviolet radiation coming from the sun are absorbed by the ozone layer in the Earth's atmosphere. I know that this is common sense and you know this already. Next, the UV rays in the large quantity produce harmful effect on human being. I think you know this already because there are so many UV lotions out there in the market. It causes the production of melanin that causes darkness or tanning of the skin. So I think that you guys already know these 2 points. Moving on. It is absorbed by an ordinary glass. So even an ordinary glass has the capacity, the glass I am wearing, to absorb the ultraviolet radiation. So sir, why do they sell UV cut glasses? Because they absorb it more. Next. So now the uses of ultraviolet radiation. It has got uses, yes. It has got many uses for the future doctors. Let's see. The first one. Due to its short wavelength, it can be focused into very narrow beam, which is used for high precision application. Example, LASIK, the eye surgery, which I wanted to get for the last 5 years, but I am just delaying because I can't take 14 days of break. So for LASIK, we use ultraviolet radiation. And this is the whole name of the procedure if you wish to remember it. Actually, even I remember laser assisted in situ. After that, I do not remember. Next thing, bachcho. UV lamps are used to kill germ in water purifier. In all the water purifiers, you will find RO plus UV. Okay, so it is used to kill pathogens. Next, to destroy the bacteria and for sterilizing the surgical instruments. After performing a surgery, the doctors wash their instruments and then they place it inside a box which contain a UV lamp. And that UV lamp makes sure that if there are any bacteria present over the surgical instrument, they die out. Next, bachcho. The important note that is given in NCERT and you should know is this. Ozone layer in the atmosphere plays a protective role and hence its depletion by CFCs gas such as freon is a matter of international concern. So you should know that the ozone layer depletion is taking place due to the presence of chlorofluorocarbon gases, and one such gas mentioned in NCERT is freon. Moving on to the next type of rays, which is X-rays. Now, its frequency is of the order of 10 to the power of 16 Hz to 10 to the power of 21 Hz. Look that they have got high frequency. High frequency means more energy. Its wavelength lies between 10 nanometer to 10 to the power of -4 nanometer. So the wavelength is quite less, energy is quite high. It is produced in a tube called modern X-ray tube. Next point, it is detected by a photographic plate, Geiger tube and ionization chamber. All these are just fact points, you need to remember them. Next, X-rays are used as a diagnostic tool in medicine and as a treatment for certain forms of cancer. So remember that X-rays are used for treatment of certain form of cancers. Next, in engineering, it is used for detecting faults, cracks, flaws and holes. Definitely even orthopedics use it to find out the cracks in the bone. Next beta, it is used for detecting pearls in the oyster. So which of the EM wave is used for detecting pearl in the oyster? X-rays. Defect in rubber tire and gold. So these are some facts that you need to read and remember. Just this much, that in an objective question within the 4 options you can mark it out. Now talking about the last type of EM wave, that is gamma rays. Now the most important thing you need to remember here is that gamma rays are produced inside the nucleus. So they are produced during the nuclear reactions. So it is high frequency radiation, highest of them all, most energetic of them all, which is produced in nuclear reaction. Which type of force is the strongest force? The nuclear force. The strongest force gives out the strongest types of photons, and this most energetic wave is called X-rays. Now they are emitted by radioactive nuclei. Just need to remember this. Its frequency range from 10 to the power of 15 Hz, such big, to 10 to the power of 22 Hz. Next, it is detected by photographic plate, Geiger tube, ionization chambers, same as what we said for X-rays. Next, they show phosphorescence, fluorescence, polarization, diffraction. So gamma rays are not different from our ordinary light. It also shows polarization as well as diffraction. Next bachcho, they have very high penetrating power. So this is asked that out of alpha particles, beta particles and gamma rays, which one penetrates through the lead block the most? So gamma rays are rays, they are photons, they are the smallest, so they penetrate the most, as well as gamma rays have got highest energy. So they have got more momentum associated with them. So now that's all for this hour. I recommend you reading NCERT of this particular chapter once. See you guys in next hour, where we are going to start the super duper awesome topic of optics. See you guys in next hour. Bye bye. So that's all for now. See you guys in the next hour.